Cancer has traditionally been treated as a disease of old age. Cells accumulate damage over decades, repair systems become less reliable, and the risk of a dangerous mutation gradually rises. That explanation still holds true for most cancers. Yet something unexpected has been happening across multiple countries. More adults are being diagnosed before age 50. Colorectal, uterine, lung, breast, kidney, and several gastrointestinal cancers have shown troubling increases among younger generations. Better screening explains part of the pattern, but it cannot explain everything. Researchers have spent years investigating possible causes, from obesity and ultra-processed food to pollution, disrupted sleep, medications, inactivity, and changes in the gut microbiome. A major study published in Nature Medicine proposes a way these different pressures may be connected. Younger generations may not simply be developing cancer earlier. Some may also be aging biologically faster. Your chronological age is the number printed on your birth certificate. Your biological age describes how old your body appears based on its internal condition. Two people can both be 40 years old while showing very different levels of inflammation, metabolic dysfunction, organ decline, and disease risk. The new study examined data from more than 154,000 younger adults in the UK Biobank. Researchers calculated a biological aging measurement known as phenoage using routine clinical markers such as blood chemistry and immune-related measurements. They then compared people born in different periods. The pattern was striking. Participants born between 1965 and 1974 showed greater biological age acceleration than those born between 1950 and 1954. In a separate American dataset, people born during the 1990s also showed substantially greater age acceleration than participants born several decades earlier. This does not mean that every young adult today is biologically older than their parents were at the same age. It means that, at the population level, newer birth groups showed biological profiles associated with faster aging. The researchers then asked the most important question: did this accelerated aging predict cancer diagnosed at a younger age? The answer was yes, although the size of the association varied by cancer type and by the biological clock used. In the main UK analysis, each standard increase in the phenoage age gap was associated with an 8% higher risk of early-onset solid cancer. The relationship appeared stronger for particular diseases. Faster systemic aging was associated with greater risks of early-onset lung, gastrointestinal, colorectal, and uterine cancers. People in the highest third of biological age acceleration had about a 15% higher overall risk of early-onset solid cancer than those in the lowest third. Those numbers require careful interpretation. An 8 or 15% increase in relative risk does not mean that 8 or 15% of biologically older young adults will develop cancer. The absolute risk for an individual may still be low. The study identifies a statistical association across large populations, not a diagnosis for any one person. The researchers also tested other ways of estimating biological aging. One method used clinical measurements. Another used metabolites circulating in the blood. The results were not identical, but several important patterns pointed in the same direction, especially for early-onset lung and gastrointestinal cancers. Then the scientists went deeper. The body does not age as a single unit. Your brain, immune system, fat tissue, liver, lungs, kidneys, and muscles can age at different speeds. Someone may have a relatively youthful heart, but an older immune system. Another person may show accelerated aging mainly in metabolic tissues. Using thousands of proteins found in blood, researchers estimated the biological condition of individual organs and tissues. These organ-specific measurements revealed two particularly interesting associations. Accelerated immune system aging was linked to early-onset lung cancer. Accelerated aging of adipose tissue, meaning body fat tissue, was linked to early-onset colorectal cancer. These connections remained even after the researchers accounted for overall systemic aging, suggesting that aging within specific tissues may add information beyond a single whole-body age score. The lung finding offers one possible biological story. The respiratory system is continuously exposed to the outside world. Tobacco smoke, air pollution, workplace chemicals, infections, and chronic inflammation can reshape both lung tissue and immune activity. An aging immune system may become less effective at identifying and destroying abnormal cells before they become tumors. It may also create persistent inflammatory conditions that support cancer development. However, the study did not prove that immune aging directly causes lung cancer. It showed that the two were associated. The colorectal finding may involve the relationship between body fat, metabolism, and the gut. Adipose tissue is not merely a storage container for excess calories. It behaves like an active organ, releasing hormones and inflammatory signals that influence insulin, immune function, and tissue growth. Aging fat tissue can become dysfunctional. It may store fat less safely, release more inflammatory molecules, and disrupt communication with the liver, muscles, and intestines. Visceral fat around the abdominal organs may be especially important because of its close relationship with insulin resistance and chronic inflammation. This could help explain why metabolic health may matter even in younger people who do not appear visibly ill. The research does not suggest that one biological aging test can currently predict who will get cancer. Biological clocks remain experimental tools. Different clocks measure different features, and a person may receive different biological age estimates depending on the method. PhenoAge, for example, is designed partly around patterns associated with disease and mortality. A metabolomic clock studies small molecules produced through metabolism. Protomic clocks examine proteins. Epigenetic clocks analyze chemical markers attached to DNA. These clocks overlap, but they are not interchangeable. They are more like different camera angles than a single perfect measurement. The study also has limitations. It was observational. Researchers measured biological aging markers and followed cancer outcomes, but they did not randomly assign people to age faster or slower. Therefore, they cannot prove that accelerated biological aging caused the cancers. Reverse causation is another concern. An undetected tumor might alter inflammation, metabolism, or blood measurements before diagnosis, making the body appear biologically older. The researchers performed analyses designed to reduce this possibility, including excluding cancers detected soon after measurements, but it cannot be eliminated completely. The UK Biobank also does not perfectly represent the general population. Participants are often healthier than average, and some racial and socioeconomic groups are underrepresented. The American validation group was smaller and recorded only 104 early-onset solid cancers during the analyzed follow-up. The organ-specific results were based on an even smaller subset and therefore need replication. Still, the study matters because it offers a framework that may connect many suspected risk factors. A person's biological age reflects the cumulative effects of numerous exposures. Poor diet, smoking, alcohol, physical inactivity, obesity, pollution, chronic stress, inadequate sleep, infections, and social disadvantage may all leave measurable traces in the body. Instead of asking whether one modern habit caused the increase in young cancer cases, scientists may need to ask how multiple exposures combine to push certain tissues into an older and more vulnerable biological state. This may also help explain generational differences. People born in different decades have experienced different food environments, chemical exposures, childhood conditions, antibiotic use, sleep patterns, levels of physical activity, and rates of obesity. These influences can begin early. Childhood nutrition, maternal health, stress, and environmental exposure may shape metabolism and immune function long before cancer appears. Biological aging may become a record of those accumulated pressures. There is an important danger in discussing this research. People diagnosed with cancer should not be blamed for aging badly or living incorrectly. Cancer is influenced by inherited genetics, random cellular events, environmental conditions, infections, medical history, and factors beyond personal control. Healthy people can develop cancer, while people with unhealthy habits may never receive a diagnosis. Biological aging is not a moral score. The study also does not justify purchasing unregulated biological age tests or extreme anti-aging treatments. There is currently no proven method for reversing an age clock score that guarantees cancer prevention. The practical message remains less dramatic. Avoid tobacco. Maintain a healthy body composition when possible. Stay physically active. Eat a diet rich in minimally processed foods and fiber. Limit excessive alcohol. Protect sleep. Attend appropriate screening. Do not ignore persistent symptoms because you believe you are too young for cancer. Symptoms such as unexplained weight loss, unusual bleeding, persistent coughing, a changing lump, long-lasting digestive changes, or unexplained fatigue deserve medical attention regardless of age. Researchers hope that biological aging measurements may eventually improve prevention. A future blood test could potentially identify younger adults whose tissues show abnormal aging and who might benefit from earlier screening or more intensive risk reduction. But that future is not here yet. For now, the most significant discovery is not that scientists have found one cause of early-onset cancer. They have found evidence that the bodies of recent generations may be carrying a greater accumulated biological burden at younger ages. Cancer may still be strongly connected to aging. The unsettling possibility is that, for some people, aging is beginning earlier than the calendar suggests.